Among the countless stars scattered across the vast Milky Way, there are billions of planets orbiting in silent harmony. Somewhere within that grand expanse lies the tantalizing possibility that intelligent life might not be exclusive to our small blue world. This idea isn't confined to science fiction. It's a scientific mystery humanity has long been determined to unravel. Today, we journey into the unknown, exploring the possibilities of life beyond Earth and the future that might one day see us crossing the stars to meet it. In previous discussions about the paradox of silence in the cosmos, why the universe seems so likely to harbor life, yet remains eerily quiet, we confronted the question, where is everybody? But now, our focus turns to an even more ambitious idea. Not merely wondering if intelligent beings exist out there, but understanding how we might one day reach them. Humanity has always looked toward the heavens with curiosity and determination. With emerging technologies and new theoretical concepts, we may soon take the first steps toward becoming an interstellar species, the very explorers and visitors we've long imagined from distant worlds. This vision doesn't just inspire awe, it redefines our place in the universe and the meaning of life itself. Within our own solar system, the search for life takes on a more tangible form. While intelligent civilizations nearby seem unlikely, the discovery of microbial life, living or fossilized, remains a real and thrilling possibility. Take for instance the Red Planet, not far from us, a world of dried river valleys and ancient lake beds that has captivated human imagination for centuries. It may have once held flowing water, and perhaps even life. But it isn't alone. Other icy moons and planets orbiting giant worlds also conceal mysteries beneath their surfaces. One such icy moon orbiting a distant gas giant has long fascinated scientists. Hidden beneath its thick crust of ice may be a vast ocean, potentially containing more water than all of Earth's seas combined. The idea that life might thrive in those dark pressurized depths is not far-fetched. Future missions are being designed to study its environment and determine whether such oceans could harbor the basic ingredients of life. However, the road to discovery is far from easy. The radiation near such planets is lethal, capable of destroying unprotected machines within hours. Even the most advanced robotic explorers face immense challenges in surviving, let alone collecting samples. Human missions to these worlds remain out of reach for now. If exploring a nearby moon within our own solar system is already so difficult, what hope do we have of reaching planets that orbit stars many light years away? Scientists have proposed two major paths forward. The first is the concept of a generation ship, a massive, self-sustaining vessel that travels between the stars at a fraction of light speed. Such a journey could take hundreds or even thousands of years. The people who first board the ship would never see their destination. Their descendants would be the ones to arrive. But this solution has its own paradox. During the centuries of travel, civilization back on Earth might invent faster technology, sending newer ships that could reach the destination first. The idea, while fascinating, raises questions about practicality and purpose. The second path forward lies in improving propulsion itself, building engines capable of achieving far greater speeds than anything we have today. One promising direction involves nuclear propulsion, where the immense energy of atomic reactions is used to propel spacecraft. In theory, such systems could reduce travel time within our solar system dramatically,
For example, cutting a journey to the red planet from months down to mere weeks. A nuclear-powered rocket could reach extraordinary velocities, pushing the boundaries of where humans can go. Even so, space remains vast beyond comprehension. The closest star system to us is more than 4 light-years away. With even the fastest theoretical nuclear engines, it would still take tens of thousands of years to get there. Clearly, a leap in propulsion technology is required. Enter the idea of nuclear pulse propulsion, which uses a series of controlled nuclear explosions behind the craft to push it forward. This concept could theoretically accelerate a ship to several % of the speed of light, fast enough to reach the nearest stars in a century or so. It's still an idea on paper, but it represents a huge step closer to true interstellar travel. Other futuristic designs imagine spacecraft powered by light itself, enormous reflective sails pushed forward by powerful lasers. These so-called light sail probes could travel at speeds up to 20% of light's velocity. Such technology could send small robotic explorers to nearby exoplanets, distant worlds orbiting other stars, and send back data across the void. It would be humanity's first true step toward touching another sun.
Targets is a small, rocky planet located just beyond our nearest star. It lies within the region where temperatures could allow liquid water to exist, the so-called habitable zone. This world has captured scientists' imagination as a possible second home, a place where life might already exist or where humans might one day set foot. Further beyond lies a fascinating world orbiting a dim red star, slightly larger than Earth but still rocky in nature. Positioned in the right zone for water to remain liquid, it presents yet another potential cradle for life. Its thick atmosphere could protect against radiation and help maintain stability, the kind of balance life needs to begin and evolve. Then there are the worlds belonging to distant star systems where several planets orbit close together, some of which also lie within their star's habitable zone. One such system, about 40 light-years away, contains multiple Earth-sized planets that could hold water on their surfaces. Each one could tell a different story about how life might emerge under alien suns. Even more distant still are planets hundreds of light-years from us, worlds so far away that if an intelligent observer there looked toward Earth, they'd see our planet as it was centuries ago. The sheer scale of the universe reminds us that looking into space is also looking back in time. These distances highlight not just how far we must go, but how much we still have to learn. The appeal of these distant Earth-like planets lies in their potential for habitability, stable orbits, liquid water, and long-lived stars that provide steady energy for billions of years. Yet reaching them would take millennia with any current or foreseeable propulsion system. The limitations of distance are a humbling reminder of our technological infancy. Still, human imagination refuses to stop there. Theoretical physics has proposed astonishing possibilities, such as manipulating the very fabric of space-time to move faster than light. This concept, sometimes called space-time warping, suggests that a ship could compress space in front of it and expand space behind it, effectively riding a wave through the universe without breaking the cosmic speed limit. Though such ideas remain far from reality, they offer a glimpse into what the distant future of exploration might hold. One day, humanity might not just observe the stars, but travel among them, not as wanderers lost in the dark, but as explorers expanding the boundaries of life and knowledge. As we stand today, gazing at the stars that have inspired our ancestors for millennia, we are on the threshold of a new era. Whether through robotic explorers, generational voyages, or breakthroughs in physics yet to come, the dream of reaching other worlds continues to guide us. The universe is vast, mysterious, and waiting. Somewhere among those endless points of light, perhaps there is another civilization looking back, wondering if they too are alone.
And when we finally make that first true step beyond our home star, we will not just be searching for life, we will be discovering what it truly means to be alive in the cosmos.